Hello guys, am I audible? Great. Let's just wait for a few more minutes. Let others join, then we can start. I don't think so. We will be having a lot of attendance today. At max 10-12 people might be joining. So yeah, welcome guys again. Uh, can you unmute your mic and just tell a bit about yourself? I don't think so. We have introduced each other. Or shall I go first? Hello. Okay. Great, great. Priyanjali, I think we have introduced. Yeah? Yes, yes. Yes, yes, yes. Samuel? Acha, acha, I got it. I remember. Yeah. Yes, yes. So I think, do you guys have any doubts? Like any doubts regarding till week 2, week 3? I mean, actually, week 4 assignment it will be released soon. Let me just cross check with Sandeep ji. Uh, okay, he will do it in few hours. So till week 3, did you guys face any doubts? I don't think so. The assignments were quite simple. The lectures were quite simple. From week 4, the problems will be starting a bit because we will be getting a lot into technical details of social networks. So any doubts till now? Okay, Samuel. Priyanjali, do you have any doubts? Okay, okay, great. Shashank, do you have any doubts till week 3? Shashank, am I audible? Yes, sir means do you have any doubts, or yes, sir means I am audible. You can unmute yourself, Shashank. Great. Do you have any doubts? Okay, no problem, no problem. So, I have a few things on the agenda today. Okay, I can solve a few problems for you, but I don't think so. Those problems would be necessary because The till week 3 the things were quite simple. The in degree out degree thing. Okay. At max, what did we have? Just a second. Let me just cross check. Small word property and this stuff. Albert Barabasi algorithm. These things, right? Am I right? Anybody, like, you guys can unmute yourself and speak. I don't think so 4 or 5 people will create a lot of nuisance. Vishal. Hello. We had till week 3 we have studied network growth models, right? Okay. 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 So by what did you study in week 2? The properties, in degree, out degree stuff, okay? Okay, so in week 3 we will be studying, who's this person? In week 3, since you are starting, we will be studying network growth models, okay? So basically, network growth models are some of the basic models that mimic real world networks, okay? So real world networks, you mean, say you have a Facebook network, you have Microsoft Outlook network, email networks. A lot of networks exist in real world. So what happens is, when we start studying the networks, real world networks, they are somewhat big, okay? And sometimes we might not be able to capture, and the data is restricted, obviously. Twitter does not give us data. So what we do is, we try to replicate them. We try to create synthetic networks that replicate the same properties as network growth models, as real world networks, okay? So these are network growth models. So there are three major properties of network growth models. Who has studied week 3? Samuel, did you study week 3? Okay. First slide. What are 3 properties of network growth models? Yes. Scale free. Yeah, local clustering coefficient and scale free. Correct? What's the meaning of these things? What is the small world property? What can you make out? What can you make up of that? Okay, if I say a property is small world property, what is the meaning of that? Kritika, let me ask one by one. Okay, Kritika, did you study week? Did you go through the videos of week 3? Hello, am I audible? Okay, Samuel, you can carry on. Okay, what is the meaning of small world property? Hello, Samuel. Yeah, please. Yes. Equation wise, you are telling it right. Equation wise, it's correct. But I want to know the intuition. Like, why do we say like networks are a small world? Small world means if the world is very small, say there are 3-4 peoples, okay, 3-4 people, the world is small. You can go to those people. You can access those people. And in social sciences, back in the day when we were in class 5th, 6th, we might have studied a phrase. We might have came across a phrase. that phrase was the world is shrinking. The world is shrinking means the means of communications, the means of transportations have increased, so the distance between people is decreasing. So the world is shrinking. So basically, small world property means that in real world networks, the average path length, okay, the average path length between two nodes is very small. Getting my point? Yeah. So it is about that only. If you go to the mathematics of that, that is the length, average path length is something log of modulus of g. G is say the number of nodes in the that something like that. Okay. Yeah. So that is small world property. And the next property is local clustering coefficient should be high. Okay. So what do we mean by that? Anyone who has studied week 3, we will go back to week 2 as well. Okay, by I'm just uh, basically speaking things for you so that when you start week 3, or you have not, if you have not started week 3, you will get to know why we are studying week 3. So from this week onwards, we will be solving previous week's assignments and stuff. We will be addressing the issues, and we will see what's upcoming in upcoming weeks we will be studying. So in that way, you will be well prepared. Okay, well prepared to solve, to basically understand what we are going to study. So basically, high clustering coefficient, local clustering coefficient means the nodes are clustered together, the communities are present in the network, and that is true. Like currently on Google Meet, there might be millions of meetings going on. There is a random network of Google Meets, but we 13 14 we 8 9 people, we have formed a very close community right now. Okay, so these close communities exist, and these close communities are found not just in social networks which are existing online, they are present locally as well. If you are studying in college itself, you might be a part of a cluster of friends. Okay, and those clusters interact with each other, but those clusters will not merge over time. They will always stay in that form. The clusters might break, but they won't generally merge. Okay, that is the real world property, that this property happens. People divide, there's a very real chance that two clusters will merge. A new person can join a cluster, but there's a very real chance that two clusters will merge. So in a real world, high local clustering coefficient means these two clusters, they are very dense. So if say if you argue, say the clusters will start merging, and ultimately all nodes will interact with all nodes. So the clustering coefficient locally, there will be no clustering coefficient that will be high, because we will be having uniform clustering coefficient. But that is not possible in real case. We don't know everyone in the world. We don't know how to interact with each other in the world. Okay, so this is what is about this local clustering coefficient. Third property. Who wants to tell apart from Samuel? Who else wants to tell? Okay, like I don't know from where the like option comes. Who has studied week 3? At least the mid of the videos. Lecture 2, at least lecture 2. Who has studied? No one. Week 2. How many of you have studied week 2 and done the assignment of week 2? Okay, chalo. How many of you have studied week 2? Guys, please respond. Otherwise, if I start solving problems, you won't be able to basically ongoing. Okay, week 1. Who has done week 1 completely? Then we will go back to basics. Okay, and later in the today's class, we will study something very different and very unique and very interesting as well. Array internet. Wait a second, guys. Am I audible? Am I audible, guys? Sorry, my internet is a bit wonky. What response is this? Yes, sir. About week 1, right? great. Uh, just a second, let me pin this thing. I have to, so I'm recording it. Okay. So yeah, what what do you guys suggest? What shall we study today? Week one basics. I don't think so. We need to go through that. These they are very basic. Okay. What do you suggest? Problem solving regarding like which week? Week one, weeks to end. Okay. What problems are you facing? What problems do you want to be solved? On what topics we will solve problems? Vishal, hello. Vishal, can you unmute yourself? What did you face any issues in week two? Okay. So you want the assignment to be discussed. I think the deadline for week two is not over yet. So in next lecture, in next problem solving session, by that time it will be over. That day we will discuss week two assignments. Apart from that, it's over. Just let me check. Let me check. Okay. Answers are given for those. I don't know. I don't know. Let me check. Just a second. Uh, this tutorial 3. What is tutorial 2? What is tutorial 1? Achha, okay, okay, okay. Shivani has taken this tutorial. Okay. Oh, okay, Maya, no, no, no. I'm going to have to go back. Answers are visible. Deadline. What's the deadline for week 2? Can you check? If the deadline is over, I can start solving. Okay. It was on 8th. And who was telling the deadline was week 1 deadline? Let me check week 1 deadline. Okay. Okay, it was on 7th. And week 2 deadline. It was also on 7th. Okay, okay. Great. This means we can start solving week 1 and week 2 assignments first, and then later on we can proceed with some cool stuff today. Okay. Are you guys ready? Like, or you guys want me to solve some other problems? Something from the book, something extra. Just a second, let me connect my iPad. Someone is waiting on the call. Everyone who has done week 2, I think the deadline is over, right? So all might have done it. Padmaja, have you done week 2 assignment? Priyadarshini? Samuel, I think you have done, right? Yes, week 2. Great, great. How much did you score? Okay, this means we have some problems in the assignment. Okay, so let us solve week 1 assignment first. Hmm? Okay, then we will go to week 2. I will share my screen. I think one sharing is possible. Let me check. Okay, can you guys open the assignments in your laptop if you're possible? Otherwise, I'll just read out the question. If, okay. So I will read out the question. Question 1 of, just a second, yeah. Assignment 1. It's open inside. Okay, great. Um, Let me pin this one. Okay. So first question is social network analysis cannot be used in healthcare domain. Uh, to map susceptible people from infected ones, etc., etc. So the answer is true or false. What was the answer? False, right? Why is the answer false, Vishal? Can you give me an example? Like I gave an example, na, from susceptible people to infected ones. Why is the answer false? Anyone? Sanjay, Samuel, Sanjay? Sanjay, hello. Uh, week 1, question 1. Okay. So why do, sorry? Okay, no problem. Okay, so just let me solve. Okay, you guys just tell me if you have any confusion. Okay. So social network analysis can be used in healthcare domain. Okay. Later when you will come across susceptible and susceptibility concept. Okay. Then we will study how we map basically a contagion, a disease, in using social network analysis. So just a second. Yeah. So there will be 2 3 models, like SIS model will be there, SIRS will be there, and etc etc. So they will tell basically susceptible, infected, then again susceptible, then recovered, then infected, and ultimately if there is also a chance that at any case the death will occur. Okay, so these models basically they are used to study an epidemic, a pandemic stuff. So a lot of factors are considered. So that's where these models come in use, and that's where social network analysis is applied in real world. Okay, this was for question 1. Let's go to question 2. In egocentric network, the central node is called alter, and its neighbors are called egos. Is this true or false? I will ask. Okay. Manjula, hello. Good evening. Correct. So say this is ego network of this node. So this node is ego, and these nodes are alters. Okay. Third question. What is the time complexity to check if an edge exists between 2 vertices I and j using an adjacency matrix? Anybody has doubt in this question? What was the answer? Who's this person? NTP? Hello? O of 1. Why is this O of 1? Hello? Okay, you. Acha. Okay. Okay, like, I mean, what, why? Correct, correct, correct. So just, okay, let me explain why is it O of 1 and why not O of I comma j or O of n or O of blah blah blah. Okay. So if I ask you, you have to find something. Find something in a matrix. So what we do is we traverse. We traverse all elements. Okay. The problem with this method is we don't know what to find. Okay, we don't know at what index does it's existing. But here we know na ki I and j, these are two nodes. Okay, so this means in this adjacency matrix at I and j you will find if the edge exists or not. You will find the weight, you can directly access it. Okay, so that is why the complexity is O of 1. Fourth question. No, no, no. You have to traverse mathematically, but we know na ki you last row last column concept is not is not say does not map to social network analysis. What is last row last column? Which means that some index node, last row means say you have 1000 nodes. Okay, so at last row you will have node 999, and last column you will have node 999. Say last 998. Okay, somewhere around that. So you know the index beforehand. Na? You know these two nodes are there. We want to check between these two nodes. If these two nodes have some mapping, they are some names. Okay, so say node. Yeah, who has where's it mentioned in options? Sorry. For all nodes it is v. Okay, or v square. You are correct. For each and every node, if you want to check, it is v square. Correct. But for a particular index, we know beforehand, it is 1. Yeah, Bidin. Got it? Vishal? Yes. Correct, correct. No, I'm not going computationally. Okay, I'm just telling it mathematically. It's a 2D array. It's a matrix. In say in C++ you will make it using 2D array. In C you will make it using 2D array. In Java you will make it using 2D array. In Python you will make it using 2D array. These are some representations of a matrix. Okay, we cannot create a matrix in those languages. But say you're in PyTorch or something, then you can create a matrix directly. There are no concept of 2D array and stuff. Okay, so if we know the index, we can access it. If we don't know the index, we have to traverse it, and that's why the complexity is 1 in this case. Correct. Yes. Yes, yes. Generally, the thing is, haha. Okay, I'll give you another example. Wait a second. Okay, I'll give another example. Okay. Huh. So I will make a graph. 1, 2, 3, 4, 5 nodes. This is 1, 2, 3, 4, 5. Okay. This is the matrix 1 or say 0 1 2 3 4, because the matrix starts from 0. I'm making it like that, 0 1 2 3 4. Okay, another row. So you can see these indexes are not mapping with these nodes, correct? We don't know where to put 1, where we don't know where to put 2. In that case, you can simply make a dictionary. Make a dictionary where you can store that node 1 is at position 0, node 2 is at position 3, node 3 is at position 5, like that. Okay, so searching this dictionary also needs complexity 1. So first of all, these indexes, even if they are mapped to a dictionary like this, to nodes, so our first task will be search dictionary to find index of node in matrix. Second task will be search that index in matrix. Complexity of this is O of 1, complexity of this is O of 1. What happened? Just a second, okay? So O of 1 plus O of 1 is equal to O of 1. That is the case. Got it? Manjula, did you get it? Great. Let's move on to the next question. How do you represent an undirected graph using an adjacency matrix? What was the answer of this question? What symmetric? What is a symmetric matrix? Does it look like this? This side is symmetric, this side is symmetric. Does it look like this? Or does it look like this? Or does it look like this? Which one is the correct? A, B, C, D. Which one is the correct one? Correct. So yeah, as we all know, when we create adjacency matrix, number of nodes come here. So these indexes are generally mapped together. So in an undirected graph, edge A to B is same as B to A. So AB. So AB is 1, then B. Let me write here A, B, B. So AB is 1 and BA is 1. So if I make it like this, say square matrix, so it is symmetric. So it is not upper triangle, it is not lower triangle, it is a symmetric matrix. Correct? Any doubts? No doubts. Let's move on to the next question. Very interesting question. Just a second. How many edges are there? How many edges are possible? How many edges are there in undirected graph with 19 nodes? 19 nodes, undirected graph. Edges. Anyone? Priyadarshini? Samuel? I know the answer. You know the answer. How? Okay, how do we come up to that formula? Mm-hmm. Correct. 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 Got it. Yeah, fine. Then we repeat it for other nodes. Okay. Yes. So yeah, whatever Samuel said, let me explain it in writing. That way you will understand it. Just, okay. So say you have n nodes. Okay. So you take out one node, and there are n minus one nodes remaining. Okay. So if I ask you, how many edges between this one node and n minus one nodes will exist? There will be n minus one edges. Okay. But then there are n nodes, total n nodes are there, and we do it for all n nodes. Sorry. Okay. So that will be n into n minus 1. But uh, if edge between A and B is existing, and then B comes again, and we start asking, say, B, C, D, okay? Then A, say there are 4 nodes, okay? Let me just redefine the problem. How many edges are existing? Then B comes up, and it will start writing A, C, D. But edge between A and B is already existing now, so we remove it. Similarly, we do it again. So basically, if we connect one node to another node, so that node is automatically connected. So this makes the edges half of the times, okay? So that's why we divided by 2. This reduces the number to half because A and B are connected, then B and A are automatically connected. So half of the edges are basically redirections. So that is why this formula, what it shows is in an undirected graph, there are half of the edges, total possible, out of all possible edges, they are half. Okay? So that you can see here, that you can see. That's why the matrix is symmetric. That is why matrix is symmetric, because only half of the edges are possible. The rest halves are simply replications of these. So that is why the matrix is symmetric. So that is why the answer is n into n minus 1 by 2. Let's solve it. 19 into 18 by 2. 9 nines are 81, 1 carry, 9 ones are 9, sorry 8 carry, that is 17, so that is 171. Any doubts? Vishal, any doubts? Padmaja, any doubts? Padmaja, are you there? I think 2-3 people have some mic issues, right? Yeah. Yeah, Padmaja. Hello. Great. Awesome. Uh, let's move on to the next question. Which of the following best describes an edge in a hypergraph? Anyone? Can connect any number of vertices, including possibly more than 2. So yeah, that sounds very sophisticated, and like it looks like you might have studied, and so I think sir has taught in PPT as well. Okay, so you want me to discuss this question? Anybody? If you want to discuss this question, just press like from wherever you will press it. I think from this emoticon option. Yeah, like this. Or you can just raise your hand. Yeah, Padmaja. Padmaja, can you unmute yourself and just let's discuss like what didn't you get from the question? Padmaja, hello. Okay, no problem. Let's discuss. Got it. You got it. That's okay. Anyway, I'll discuss it. There's no harm in discussing. These many nodes are there. Okay, so I have an edge, which means some relationship A, and there is another edge which means some relationship B. Okay, so what is the definition? What is the definition of a hypergraph? An edge can connect any number of vertices, including possibly more than two. So there's a relationship which suggests that these three nodes are in that relationship, and it again suggests that these four nodes are in relationship. This is relationship A, this is relationship B. So that is what basically an edge is represented in hypergraph. You might feel like it's a cluster, but it's not a cluster. See, a cluster in two clusters, generally it's not possible that one node can exist in two different clusters. So it has to exist in one cluster or another cluster. So that is why it's not, you should not confuse this hypergraph edge with cluster. Is not a cluster. Okay, people have this confusion a lot of times. That's why I'm clearing it up. Okay. Next question. Which of the following is not a type of network analysis? Micro, meso, mega, macro. What's the answer? Anyone? Correct. And let's discuss why megascopic is the incorrect answer. So when in a graph, we study the property of a node or an edge. Okay, this is microscopic, which is basically degree. Okay, what's other property? Say out degree, in degree, blah blah blah. These are the properties, these are microscopic. Then when we study the properties of clusters, okay, what is local clustering coefficient, okay, etc. Then this is mesoscopic. When we study the property of graph, it's macroscopic. If a graph is, say, the cyclic graph or not, if it's a cluster, sorry, if it's a fully connected graph, it's a k-click, whatever, blah blah blah, then it is these are macroscopic properties. Okay, so megascopic, megascopic, yeah, incorrect was megascopic, yeah. So megascopic is nothing. It's not a term we use in social network analysis. Eighth question is very simple, I guess. You guys might have drawn the adjacency matrix. It's not a big thing. Correct answer, I don't know if I can map 0, 1, 1, 0. Last one. Okay, great. So next question, okay. Which is a characteristic property of many real world networks? Sorry. Yeah, it's megascopic. It's which of the following is not a type of network analysis? Mhm. No. Generally, what we do is we are not studying two networks at once. In social network analysis, okay, later on in the course, you will come to know we are not studying two networks at once. Okay, in a sense, you are correct, but that is not the part of social network analysis. that is the part of, say, network theory or something. Okay. For one network, hello. What is megascopic? That is a large network. A large network itself is megascopic, right? Correct. But that network is megascopic, but that is not the type of study we do on a network. We are doing macroscopic study on that megascopic network. Getting it? The network is very mega. Mega network is there. It has million billion nodes. But we are doing macroscopic analysis on the network. We are not doing megascopic analysis. Just it is. I mean, you could have a doubt between mega and macro. That I can agree, but yeah, but micro is there. That I'm sure. Okay, micro is there because you do that degree and stuff. Now that is done on microscopic analysis. Just let me cross check once. Okay. Micro, yeah, no. Micro will not be the answer. It will be mega only. Just let me cross check. Okay, just in case. You are right, but say a ego network is there. A ego network is there. I ask what is the out degree of the ego node. Or under what category does it come? Meso, or yeah, and does it come under meso analysis? No, I'm asking you, like, what is the possible if I remove micro, then meso analysis is performed on clusters, communities, etc. We obviously micro will be there. Mega or micro can be. We can do, obviously we can do now. That is the whole point of studying degree, that centrality stuff. What is the centrality of a node? What is the between the centrality, etc., etc. That is where these properties come in picture, right? How central is the node? If attacking that node basically affects the network or not. So that is why each node is important. That is why I do these analysis on that. So say a node has very high degree. Okay, in a network a node has very high degree. It means it's connected to almost every node. And if I want to spread misinformation in that network, I will somehow convince that node that the information is correct, and that will spread the information across the whole network. So that is where microscopic study comes in picture. I want to attack that particular node. Got it? Great. Next question is the last question. Which of the following is not link-centric view of network? Anyone? Why? Okay. So link-centric view basically. Okay, yeah, let me explain. Okay. Yeah. I will explain. So link-centric view. What is link centric view? Anyone? Hello? NTP? What is link centric view? Okay, let me explain. Just see, okay? If I connect each all node, okay? So this view is one view, okay? Just a second. This view is another view, okay? So link centric view means how the links are connected and how connecting links in a different way changes the view of a network, okay? So in a unipartite graph, what is a unipartite graph? Let me just show a diagram of unipartite graph. Let me share my this screen, okay? Okay, just let me draw. So a unipartite graph is that graph. If I remove if like the node, if let me draw first bipartite graph, okay? Then we will get to know. Something like this, okay? So in a unipartite graph and a bipartite graph has two set of nodes. They are separated, they are not connected with each other in this way. They are not connected with each other. So if I remove these edges, okay, so the organization of these edges basically makes this graph unipartite, bipartite, okay? Then we have a signed graph, okay? Signed graph is there, so we add some plus, minus, something like that. But in a ego network, if I start removing edges, or like say if this node is central node, I cannot this is not if you can get the intuition, this is not a link centric view, this is a node centric view. Getting it? Hello? Did you get like why is it node centric? Why is it not link centric? Because we focus on a node, we focus on its neighbors. Here what is the focus? Where do we focus right now? We are focusing on the links between these two things. Here we know these links are existing. We don't want to study these links. We want to study the neighbors, the nodes, okay? Here also, in signed graph, we are studying the edges. Okay, in our unipartite graph also, we are studying edges plus nodes. We are not studying just nodes, but here we know already the edges are already present in a particular fashion. Edges are already present in a particular fashion. So this means we only have to study nodes. So that is why it is not a node. It is not a link centric. It is a node centric graph. Correct? Am I right, or do you guys have any confusion? Manjula? Okay. You might think I'm shouting. I'm not actually shouting. My mic doesn't work properly, so that's why I have to speak very loud. Okay, great. So yeah, I think the assignment one we have discussed it, and shall we move on to assignment two, or shall we start some coding stuff? Something you all guys want to study right now? Say, okay, how many of you know machine learning, basics of machine learning, or how many of you want to study machine learning, something like that? You know machine learning basics. Okay, so if I ask on the how many of you know supervised learning? Okay, just raise your hand. Okay, how many of you know supervised learning? Okay, how many of you know unsupervised learning? Raise your hand again. Great. How many of you know say linear regression? Okay. Logistic regression, classification algorithms basically. Logistic regression, all of you know. Awesome. Almost all of you. Okay. So, I won't go to deep learning right now. The thing is, later in the course, we will come across basics of graph neural networks, how they are trained, what loss functions are followed, blah blah stuff. So that's why I wanted to clear the basics first, and why those things are important. Will we can discuss right now. Okay, why those loss functions are important, why those training strategies are important, why test train split is important. This stuff we that they will be that sir will be discussing later on. If you want, we can discuss it right now in context of some common data sets, and then we can move on to that later in the course when you will go there. Then we can study that stuff in with respect to graphs. Vishal. Okay. See, ultimately, ultimately, what we will be studying is we will be studying classifications. Okay, classification of a node, if it's something, classification of a subgraph, classification of a link, predicting a link. Okay, and ultimately classification of a graph. These all things we are supposed to study by the end of the course. Okay, so now when I tell you these things are important, and do you guys want to study machine learning? I won't teach you what is linear regression, what is logistic regression. I will just tell you how this stuff can be mapped to our machine learning problem. Yeah, some basics of exposure of that, some sort of stuff. So that we can study right now, or we can solve week 2 assignment, and then we can come back. Like, it's up to you. You guys, whatever you want, we can start. Or you guys want to study something else? I think the videos of the course are self-explanatory, so I don't think I need to teach the content which is already in the video. If you have any doubts in that, we can study. And apart from that, I want you to basically ask questions about anything you have. Manjula, do you have any questions about anything you want to study, like whatever? Great. Next class, we will study, we will take a real world network. We will study the properties of that network. Okay, just write it, let me write it down. And next class, we will discuss, because right now we don't have time to do that much of things. Okay, but be present in next class, Manjula. Okay, sure. Great. Vishal? Uh, okay, I will go. Just a minute, just a minute. Let me write it down. Real world network analysis. So basically, these are some of the projects we used to do when we studied social network analysis. It was in our coursework at IIT Delhi. So we did some sort of projects on real world network analysis and how that network affects the real that the how the communities and stuff are affecting the network. So we studied all those things, and we will do this in Python. Network X and whatever you want. That's it. We can use some pandas, numpy. I think you guys already know these libraries. For coding, for machine learning, I know both. I know both of them. Whatever you feel comfortable, I can teach in that. Okay, but I would suggest go with PyTorch, because the thing is, PyTorch is mostly used in research a lot nowadays. So that in that way you can keep up with the codes of the papers which are coming recently in graphs. Mm-hmm. No, no. For this thing, we are not doing machine learning. Okay, machine learning we are not doing here. There's some basic network analysis which we will study in the next class. Uh, right now, I will discuss these two questions, and I will start something for say machine linear regression or something. Let's see where this class ultimately takes us. What was the doubt? Question 5 6. Just wait a second. Week 2, week 2. No, yeah, we haven't discussed it. If you want, we can discuss it. Exactly, exactly. I got your point. I got your point. That's why I will show you. Okay, just wait a week. I will show you that. I got your point, and that's what I wanted to discuss. But the thing is, the two classes we took network X, how to make a graph and blah blah blah. So we couldn't go there, but we will discuss it. We have 3 weeks aligned for these tasks. Okay, 3 4 weeks. Okay, first week, next week we will study these things, where the diameter and etc etc taking the things. Then today I will start some basics, theoretical basic. In next class I will teach you how to code machine learning, how you will be coding graphs later on. That we'll study later on when we will study PyTorch, geometric, and etc etc. But I will teach you how to do machine learning in PyTorch using TensorFlow, whatever you want. Scikit-learn also. Okay, it's basics of Scikit-learn we will do, and then ultimately we will study. What was that, Vishal? Mm, no, 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 no. No, 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 about machine learning. Week 2 assignment I will discuss right now. Yeah, 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 okay. Huh. So I want you guys to not worry about the resources, the compute. We have Google Colab. We have discussed in week 1. We will do everything on Google Colab itself. Okay. The graphs are not that big. We will be using basic embeddings, so that won't be a problem for us. So okay. So let's start week 2 assignment. Question 5 6 7. Any other questions you guys want to discuss in week 2? Anjula? Let's discuss all of them. Better. Okay, so we have a network. Questions 1 to 7. We have a network. Just let me create another page. Page. Yeah. So what is the degree? Question 1 is simple. Node 1 has degree 2. Okay. Node 3 has degree 5. Node 4 Node 4 has degree 2. Then node 2 has degree 2. Correct? What is the diameter of network? What is the diameter? Shortest? No. I mean, what is the diameter? Longest shortest path possible in a graph. Okay. So where can we see that path? Between 1, 2, 3 and 7, the 3 length path. Then 1, 3, 5 and 6, the 3 length path. 2, 3, 4, 6, like that. That is the shortest longest path. Correct. So the answer is 3. That is clear, right? Huh? And then what is the density of the network? Let me check the formula. Actually, I don't remember. Actually, I know it, but let me just cross check, okay? Network measures. Yeah, something like that. Just where's the ambulance? Density. Yes, correct. Got it. Actually, we will be going a lot through formulas, so let me just open the book with me. Yes, so screen is visible. Density of a graph is denoted by number of edges divided by possible edges. Correct? We just, how many edges are there? 1, 2, 3, 4, 8 edges, right? 8 edges are there, and possible edges is 7C2. So that is divide by 2. Yeah, it will be 21. So what is 8 by 21? Correct. You guys already know it. Okay, so when I ask what is the density of a network, I mean how dense is the network. Basics, okay? So this means how frequent, how many interactions are there in the network. So say you, that is what an interaction means. Correct? 0.38 means 38% of, say the network has an interaction of 38%. So this means say a person interacts with 38% of people in the network. That is the basic of density. So that is an average kind of thing we are doing. So if I connect each and every node with every edge, so that means the density is 100%. So each node is talking to every other node. So we have an interaction rate of 100%. We know everyone, but currently we know by this density we mean the network knows, a person knows 38% of the nodes in the network. Got it? Great. So these are the real things which are that's where the real world use case gets using these density and stuff. Okay. Question 3 is done. Question 4. What is the local clustering coefficient? Of node 5, sorry. Yeah. Question 4. No, let me solve it. I know the answer. Let me draw the network, okay. 1, 2, 3, okay, then 2 there, here, then 4, then 5, then this is connected, then 6, then 7. Okay, so for node 5, we have 2 neighbors. The neighbor is 4, the neighbor is, sorry, 6, 3 neighbors. The neighbor is 3. Yeah. Okay. So yeah. Um, so basically, local clustering coefficient is number of edges between neighbors divided by possible edges between neighbor. Currently, how many edges are there? One edge between neighbors. If I draw this, if I remove this node, okay, these edges. So how many edges are there right now? Just delete it. Just one edge is there, right? Guys, Anjula? Yes. And possible edges are how many edges possible? 3C2. That is 3 into 2 divided by 2. That is 3. 1 by 3 is 0.33. Vishal, did you get it? So I suggest you again, please guys, go through these formulas because in exam questions will come like that. And you might make mistakes to solving them because you might not remember the formula correctly. Just a second, let me have some more. Question 5. Sorry. Possible edges between neighbors. Okay. Let me draw that graph again. Node 5 is there. This is node 4. This is node 3. This is node 6. This is the graph for node 5, right? Okay. So see. Number of just let me remove this ego network, okay? Right now we have this network. Correct? The current number of edges between neighbors is no, 1. So if this network is fully connected, how many edges will be there? 3 edges. Got it? Great. Next is local clustering coefficient, degree centrality. What is the formula for degree centrality? I think my network is gone. Hello? Yeah. Degree centrality, just a second. For all nodes, okay. Degree centrality of 1, 3, 5, 7. So degree centrality of a node is, what's the formula? Okay. Out of all nodes, the screen is visible, right? Screen is, yeah, okay. Out of all nodes, let me write it down. Just a second. Sorry, here. So out of all nodes, this is U, okay? Degree of U, find the maximum degree. So one thing is sure that this denominator is going to be same for all of them, correct? Let's find out that denominator. Obviously 3 is, it has degree 1, 2, 3, 4, 5. Okay. Correct. The node is 3. This degree is 5. Denominator is 5. And you put the numerator again. Okay. So what is the numerator for 1? 2 by 5. Correct? 2 by 5. Then for node 3, we have 5 by 5. Who's there? Then for, you guys can solve later. Okay. I don't think so that is difficult anymore. Closeness centrality for node 6 and 3. Question 6. Let me write it down, don't speak the answers, okay? Closeness centrality for nodes 6 and 3. What is the formula for closeness centrality? Hello? Arey, when I ask question, everybody mutes. Speak whatever you like. You want me to derive the formula, or you want to just tell the formula? It's basically yeah, the degree thing, degree thing, something like that. Okay, yeah, you tell the formula first. Okay, then I'll derive it, something like that. Yeah. So closeness, yes, correct. Closeness centrality is the measure of reach, how reachable the node is from the rest of the network. Correct? Okay. So just let me give an example. For an ego network, what is the closeness centrality? Just assume, okay, don't compute it. So for each from each node, you can just go via one jump, okay? So getting my point, right? Hello? So you can go via one jump. So our ego network, the ego node has sort of highest closest centrality to its neighbors. So when you take the ego network into consideration, the ego node has highest closest centrality. And so are other nodes as well. So this node, it's not possible. From this node we cannot go in one hop, okay? But from this node we can go to here. So for every other alter, the closest centrality is very high, so is low compared to the ego node. So now you got the point of closeness centrality, how close the node is compared to the rest of the network. Getting my point? Manjula? No. Did you get my point, right? Why closeness centrality, how closeness centrality can be related to an ego network? Correct. Okay, so this means the closeness is basically the length between the average length, you can say the average length between two nodes. Okay, so say I have a graph, this path length something sort of thing. So I want to compute, just let me make it something. Okay, just let's go to the original graph. Okay, so for node 6, what is the, let's compute the distance. Node 6 is reachable, node 1 2 3 4 5. From node 1, what is the shortest path to node 6? 1 2 3, correct? For node 2, what is the shortest path? 1 2 3, correct? For node 3, what is the shortest path? 1 2. Node 4, 1 2. Node 5, 1. Okay, you sum it. What is the sum? 3 3 6 11. Okay, so you can see node 6 has closeness centrality of 11. Let's do it for node 3. Not, this is not closest centrality, sorry, this is the total path, total shortest path length. Let's do it for node 3. Node 1, 2, 4, 5, 6. And then I'll show you something interesting and why the formula is made like that. From node 1, the centrality is 1. Shortest path is 1. The node 2, shortest path is 1. Node 4, shortest path is 1. Node 5, shortest path, sorry, node 7 is not present. Okay, let me write it down. Node 7 here as well. Node 7, 1, 2, 3, 3. So that will be 14. Okay. For node 6, the path is 2. The node 7, path is 1. Sum it. I'm just assuming it's 7 because you told me. Okay. So, being a centrality measure, okay, just answer my question. Being a centrality measure, if I say node 6 has closeness centrality of 14 and node 3 has closeness centrality of 7, it does not make any sense, correct? Either I want to convert it to fraction or I want to convert it to something like that so that it's comparable between 0 to 1 range or 0 to 100 range. This is not comparable at any cost. So what we can do is we can divide it by number of nodes. Number of nodes is 7. Correct? Yeah, for the closest centrality is for a node. It's a microscopic property. Getting my point? For node 6 and node 3. So this is for node 6, the value is 2. For node 3, the value is 1. So you can see this is very high, this is very low. But node 3 is reachable. But so this should be high, this should be low. Correct? So that's why we invert the formula. We do it for say V or V minus 1 by this summation of degree. In that way, so if I'm taking it 14 because I want the number to be say 0.5 or something. So for 14 by 7 and then 7 by 7, this value is 0.5, this is 1. So closeness centrality for node 3 is 1, for node 6 is 0.5. But we are using the formula V minus 1. So that's why it will be 13 by 7 and 6 by 7, something. Correct? Manjula, where's NTP? Okay, let me do it again. I will take another example, but just let me explain. So summation, let me write it down. For node 6, summation is 14. For node 3, summation is 7. Okay, these values are, yeah, great. Up to this, if it's clear, then it's the next part is very simple. You will see. Okay, so see here, this 14, this 7, this does not tell anything. This does not tell anything to us. Yeah, what does it mean? Blah blah blah. It doesn't tell anything at all. What is the closeness centrality is 14? It doesn't mean anything. We want to convert it to some fraction sort of thing. Correct? Getting my point, right? Why we are converting that to fraction? If I say we can say, but yeah, we can take, but say like we did not degree centrality sort of thing. What we did last question when we said, yeah, density. Okay, so when we said the density is 0.38, so which means 38%. Each node interacts with 38% of other nodes. Correct? So that is why we are converting it to fraction, so that we can say, yeah, what is that? The closeness centrality means that the node is close. 38% of the nodes are closer to this node, something like that. We want to make something. We want to make it sound like fraction or percentage sort of thing. That's why we want to convert it to something like that. Okay. So yeah. So next part is simple. So then 14. If you divide by number of nodes, 14 by 7, 7 by 7. So that will be 2. That will be 1. It's still C. So node 6 is very far, but its closeness centrality is high. That sounds ambiguous, right? Not ambiguous, say contradictory. That sounds contradictory. So that's why we turn these numbers around. We make numerator to denominator like that. So 7 by 14 and 7 by 7. And then we do n minus 1. So that is, I think, 6 by 14 and 6 by 7. So when you do, you get 0.4 to 0.98, something like that you will get. Getting my point? Why are we doing minus 1? Why? Why? That's what I'm asking, na? Why? Correct. That one node we are taking into consideration. We are using other nodes with respect to that. So that's why we are removing that node. Just a second. That's why we are removing that node which we are taking into consideration to compute the centrality. That is why it is v minus 1. Yes. Obviously, see. How many nodes are there? 6 nodes are there? 6 nodes are there? This node is not there, this node is not there. That's why we do v minus 1. Got it? Next question. Let me drink water. Till now, everything is clear, right? Manjula, NTP, what's your name? Okay. Acha. Just a second. Okay, let me reshare my screen. If this session extends till say 8:10, 8:15, do you guys have any problem? Or you guys have some other plans to go? Great. The thing is, I want to discuss these all things. And in next class, we will do coding again. Next class, we will do coding. Screen is visible, right? Great. We discussed till question 6. Question 6. Hello. Then let's discuss question 7. Out of which pair of nodes out of 2, 3, 6 are closer to each other according to Jaccard similarity? What is Jaccard similarity? Anybody? Formula. Hello. Intersection by union of what? Two nodes. So what? Like, what is the intersection? Neighbors, double neighbors, total number of nodes. What is that? What is the intersection by union? Neighbors or paths? Google search and tell me in graph social network analysis what is Jaccard similarity? Anybody else by then? Manjula, what is Jaccard similarity? Sriram? Hello Sriram. Paths. What paths? What paths actually? That's what I'm asking. Within a node. Okay, just a second now. Okay, somebody can somebody just a second, okay? Are you sure it's it's paths and not neighbors? I'm unsure about that. It is neighbors. It is neighbors. It is neighbors. So basically, let me just explain it intuitively first, and then. Okay, screen is visible. Screen is visible, right? Okay. What was the network? I cannot go back again and again. Just let me redraw it again. 1, 2, 3, 5, 4, 7, 6. Hop, hop. 1, 2, 3, 4, 5, 6, 7. So between nodes 2 and 3, node 2 and node 3, okay, what common neighbors do they have? Okay, just wait a second, let me just write it down. Neighbors of node 2 are 1 and 3. Neighbors of node 3, 1, 2, 4, 1, 2, 4, 5, 7. Union of them is 1, 2, 3, 4, 5, 7. Intersection 1. 1 by 7. Okay. Sorry, 1 by 6. Okay, got it? And then for node, this is for node 2 and 3. Okay. So one node and 2 and 3, this is 1 by 6. Somebody do it for node 2 and 6. Okay, Manjula, do it for node 2 and 6. Let me do it again. Let me do it parallelly. For node 6, neighbors is 5. Okay. So intersection is 5. Union is 1, 2, 4, 5, 7. That is 5 nodes. That is 1 by 5. So between 2 and 3, it is 1 by 6. Between 3 and 6, it is 1 by 5. Between nodes 2 and 6, 0. Correct? Why is it 0? Because intersection is... Leave it. I'm doing it now. So, why is it 0? Correct. There's no intersection. Let me write the formula. Manjula has some confusion on formula. So, basically, Jaccard similarity between A comma B is neighbors of A intersection neighbors of B. This is count. Okay. Then similarly, neighbors of A union neighbors of B. Okay. So for node 2 and 6, 2 has neighbors 1 and 3, 6 has neighbor 5. Intersection is null set. Jaccard similarity between 2 and 6 is 0. For nodes 2 and 3, it was 1 by 6. For node 3 and 6, it was 1 by 5. What is higher? 1 by 5. So that will be 3 and 6. Correct? We all are lost. Okay. Who else wants me to explain? I will explain it clearly then. Manjula, did you get it? Leave it. Don't I'm just saying you get the concept or not. Question 7, let me do it again. There was a lot of stuff going on. Let's do it again. Node 1, node 3. What was the node? 5, then 6, then 7. Okay. This is 4. This is 2. This is connected. Okay. So formula is intersection B by A union B, the count. This is basically neighborhood. So for neighbors of 2 are 1 and 3. Neighbors of 3 are 1, 2, 4, 5, 7. Neighbors of 6 are 5. Just one node. Okay. So neighbors of 2 intersection neighbors of 3 is 1. Okay. So count of this is 1 by union. Union is 6. Correct? Okay. Then similarly for 3 and 6, intersection is node 5. So count of this is, count of 5 is 1. So 1 by 5. But intersection of n6 and n2 is 0. So sorry, null set. So count of 5 is simply 0. So 0 by 1, 3, 5, 3. That is 0. So the lowest, the highest Jacquard similarity is between 3 and 6. That is why 3 and 6 are the closest nodes to each other. Got it? 2,6. Yes, for all possible combinations. Okay. Had there been 4 nodes, you would have to do for all. How many combinations are there? For combinations of all 4 nodes, basically. Okay. You have to take the maximum. Minimum is 0. Minimum is 0 between 2 and 6. Got it? Great. Let's go to question 8. What is question 8? In a linearly / chained connected graph with n nodes, mean degree is 1.9. How many nodes are there in the graph? NTP, what's the answer? No. Just tell me the answer. You did the question, right? What's the answer? What answer did you mark? Your answer was correct? Correct. Great. Awesome. Don't worry about the calculation. I'm doing it. Okay. Just a second. I think it's raining. So what is a linear graph? Linear graph is something this. Correct? Correct? So let me just show you. So for a graph with n nodes, the edges will be n minus 1. Okay? That is correct, right? What is the formula for mean degree? Somewhat correct, but that is not the correct answer. Sriram, what is mean degree? What is the formula for mean degree? No problem, no problem. No problem, no problem. Okay. Okay, okay, okay. Sure, 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 sure. Okay, okay, no problem. Manjula, what is mean degree? It's something number of edges by number of nodes, something sort of that. Tell me the exact formula. Everyone, hello? Ah, shit. Hello? Hello? Actually, it's raining now, so Wi-Fi goes down in IIT in between. Just a second. Let me share my screen. Okay, formula for mean degree. Array, mean degree, simple formula. Hmm? Almost correct. Yes, 2e by n. Correct, Sriram. 2e by n is the formula for mean degree. Yeah, I agree. Total degree is, but I wanted to know in the form of edge and notes because I've written it correctly, like in that way, na. If I write it in, just a second. If I write it in that way in total number of degree, then I have to compute degree for each and every node. Okay, so yeah, yeah. So formula is 2e by n, that is 1.9. 2 into n minus 1 by n is equal to 1.9. 2n minus 2 is equal to 1.9. What do you think? 1.99, sorry. Huh? So that is 0.1 n is equal to 2, n is equal to 20. Correct? That is the answer. In a circular cyclic network, just a second. Question number 9. In a circular slash cyclic network with n nodes, what is the mean degree? Two n divided by n, that is 2. Correct. Last question. Why is it 2n? Because number of edges is equal to number of nodes, because we are basically connecting this edge. Yes. Yes, because we are connecting this back, so number of nodes is equal to number of edges. Okay. It's done in the class. Great, great. Acha, acha, acha. Actually, this is the famous question of sir. I thought he didn't teach, but actually just been basically between the centrality and closeness centrality, between the centrality. These are the two measures which are used to spread information, get information. This thing. Okay. So yeah, that's all then, I guess. Any other thing you want to discuss? Uh-huh. Power law, I didn't do in that depth, I just discussed it. Okay, what is power law? Forget it, forget it. I will just tell you simple definition of power law. Proportionality, etc. Forget it. What is this distribution? Exponential distribution, right? Power law is somewhat similar to this. Okay? That's why the equation is written L into log of this is n. So n is proportional to exponential of L. That's right now. So that is basically exponential equation. So what does it tell about the node? Let me just explain power law first, and then we will go to what part did it have? Just a sec. It's in chapter 3, right? Sorry, week 3. Small world property. Synthetic networks, scale free property. Yeah, scale free or small world? Scale free property. Yeah. Yeah. Okay. So say this is the number of nodes, or say this is degree, whatever you want. Like this is degree, or this is the number of nodes. Okay. So it tells when the nodes are this much, when the nodes are say two or three nodes, out of the whole nodes will have very high degree, and all other nodes, say others say 10,000 nodes, something like that, will have very low degree. This is the basic of power law, which is used in say NLP as well. So just let me think of an example. I used to study in NLP. Sort of, yeah, some from n grams or something. Do you remember? Acha. Okay. Okay. So it was something related to that only. So it was say, yeah. Occurrence of words. So words with large length. Okay. Larger words occur less number of times compared to smaller words. It was something like that. Yeah, Pareto plot. Basically, yeah. So Pareto plot is basically linked to power law only. Okay, and when we want to check if a graph follows Pareto law and Pareto plot or not, we basically apply log on that. If that's a straight line, so that means it follows Pareto plot. Okay, so if I give that, say this sum a is directly proportional to exponential of k, this is given. Okay, the plot is given. You want to know it follows power law or not, correct? So how will you come to know? You cannot just see a distribution and tell it's exponential. Apply log on both sides. Log of a is directly proportional to log of exponential of k. So that basically gives log of a is directly proportional to k. So this scale changes to log of a is directly proportional to k. So this basically converts this distribution to a straight line. And when you do when you check if when you say basically it might be something zigzag or something, you get it, the best fit will be a straight line. So that is why we apply log on Pareto law and power law to check if the distribution is following that or not. Yes. In fact, not just in power law, there is one other thing. KK plot or something. Basically you can use KK plot as well. So take another exponential graph. Okay, you know the base of this exponentiation. Okay, you create another graph with same exponentiation. You get two graph A, graph B. Okay, when you start and then how will you check? So what you do is you have the data. You have data at each point. What you do is you apply percentiles over that data. It's something like that. KK plot. Just sorry, QQ plot. QQ plot. Yeah. Yeah. Yes, yes. So it is for normal distribution. You take normal distribution from data from normal distribution to come. Yes, residuals. Yeah. So here in QQ plot, you can just take another exponential graph, and if it's a straight line, it's exponentiation. So you can use that as well. Hmm. Yes, correct. Because these things I studied long time back. So I don't have any like I need to refresh that. So yeah, that's all, guys. I think any other thing you want to discuss? Sridham, just wait a second. Let me just ask everybody else. Sure. Bishal, Manjula, and TP, do you have any other doubts? Manjula? So it's just given the video, as Shriram said, na. So if you go through the video again, you will see. But basically, I have to explain it. Will take a lot of time. Sir has explained it clearly in that video. Okay. Just go through once. If you not get it, we can discuss in the next class. Okay. Okay. Cool. Anybody else? Any doubts? Okay. Bishal. Week 3. Yeah. Week 3 we'll discuss next week. Hope Barabasi algorithm, blah blah blah. We'll study next week. Sorry, I don't know. I don't know. I seriously don't know. You need to ask the people, the NPTEL people. You can ask. You can email them. You can email them and ask because I have no contact with them. I don't know the date, even the date of the exam. Because I just know they asked me to make the question paper. I made the question paper. That's all did. I don't do anything else. Yeah. Okay then, guys. That's all I think. Uh, Shriram, you want to discuss? Yeah, we can start. Like 4 5 minutes we can take up because 8:30 my dinner will start, so I have to leave. I will 8:30, but it will stop at 8:30. The miss. Yeah, yeah. No, I don't know. E. Sampat Kumar. Ach. Yes, yes. Just searching. Yeah, okay. Got it. I, my guide knows him. I don't know if I knows. He might be knowing him. I don't know. I don't know. Okay. Oh. Okay. Extremely sorry, Evan. Oh.